You can see sort of the waving and that sort of thing. Okay, great guys. So we'll get started. All right, welcome to class, guys. So yeah, today we're talking about section 2.5. In this week's module, we should have completed, or we should complete 2.4 and 2.5 by next Monday at 11:59 p.m. Again, there was originally a quiz there, but I decided to cancel it since that day's a holiday. So if you get everything finished before then there's nothing you have to do for this class on that Monday. We won't have a Q&A session either. So just have sort of a nice day off on that Monday. I'll send some more information about the next module and its contents later on today, so you can expect that. Today we're talking about the idea of quadratics, and this is the main reason why we needed to talk about complex numbers on Wednesday. In order to tell the complete story about solving a quadratic, we really needed to introduce the idea of a complex number and imaginary numbers. So let's go through the learning objectives for today. And as always, just let me know if you see sort of the video freeze or you can't hear the audio, and we can sort of fix those issues hopefully as quickly as possible. Okay, so typically I start with the learning objectives, and this is no different. For section 2.5, there are three main learning objectives. We're going to talk about what a quadratic equation is here in a moment, if you've never seen one, or that's a term that's not familiar to you. But we'll talk about how to solve quadratic equations. The easiest method is by factoring. So we've spent some time reminding ourselves of factoring and practicing factoring at infinity. So the easiest way to solve a quadratic equation is by the method of factoring. And so if you can factor, you should. Now, sometimes it's hard to factor. It may not be easy to see how the equation factors, or it may not factor at all, right? There's not really a nice, precise way to factor it at all. And in those cases, what we do is we use the method of completing the square. So that's our second objective there. And then the third is to solve quadratic equations by using what's called the quadratic formula. And the quadratic formula will come from completing the square. Okay, and I see that Wilson, Isaiah, I'd have to sort of check my details, so send me an email later and I'll check that out. Wilson is asking, are we going to submit our homework and stuff on Labor Day? Yeah, so the due date will still be there. If you would like, you can get done sort of early with it. There's one less assignment than last week, so I think that sort of makes it a little bit easier for everybody. But yeah, it'll still be a due date of 11:59 p.m. on that Monday. Okay, so those of you going on to calculus, the second objective is probably the most important from today, right? This notion of completing the square, for those of you taking Calc 1 and Calc 2, will come up again. So your calculus professor will sort of assume that you have a background in completing the square. Yeah, there's no quiz, Wilson, so that's been canceled for that Monday, so that you can enjoy your holiday. Okay, so yeah, completing the square, like I said, for you calculus students is going to be incredibly important. In terms of like the practicalities of solving a quadratic equation, it's probably maybe not the method that you'll want to necessarily use, right? Especially if you're not going on to calculus or something like that. Okay, but it is where the quadratic formula comes from. So for those of you who've never seen a quadratic equation, here's what we mean by it. So a quadratic equation here. The textbook calls it an equation, but it's any equation that's equivalent to this one. So you could add and subtract things to this equation, multiply both sides by something. So anything that's equivalent to this one, right? So anything that's equivalent to this is called a quadratic equation. And what it looks like is a second degree polynomial. So that's an x squared is the largest degree. There's an x, and there's a term without x. And the coefficient of the x squared term is typically called a. The coefficient of the x term is typically called b, and the term that doesn't have an x on it is called c, and we often will say that's the constant term. And this a, b, and c are real numbers. And what we mean by real numbers is that usually with these problems, we'll specify exactly what a, b, and c are, right? So we'll give you like 2, 3, or an actual number there. The only condition that you have to be careful with is the a can't be equal to 0, right? And that makes sense. If the a was equal to 0, we just have something like bx plus c is equal to 0. That's a linear equation, and we've already talked about those. So this really only pertains to things where the a is non-zero. And then this format has a certain name. So if you move everything to one side of a quadratic equation like this and put it in this sort of descending order, we call that the standard form. Okay, so anything that's equivalent to an equation like this is called a quadratic equation. And what we're going to be interested in doing are finding solutions to this equation. We want to find values of x, real or complex, such that when we plug them into the left-hand side of this equation, we compute x squared times a plus bx plus c, that when we do that computation, we get back the right-hand side, which is 0, right? And it turns out sometimes there is one solution, and sometimes there are two solutions. And when there are two solutions, you could even have complex conjugate pairs showing up. So we'll talk more about complex numbers sort of at the end of class today. But yeah, I'm going to pause for a moment in case anybody was listening to me and wants to just write down the definition of a quadratic equation. And also, you know, if you have a question, let me know. If you've already had enough time to write it down, give me a thumbs up in the chat, and that way I'll know when to move on. Remember, you can always come back and watch the recording and pick up something that you might have missed. Okay, thanks, guys. Brittany, I see your hand went up, but I think maybe you're just doing the thumbs up thing. So let me know in the chat if you have an actual question. Okay, so what are the two properties that we need? So the two things that we need in order to complete the square and to use the quadratic formula and factoring to solve quadratic equations are the zero factor property and what we call the root property. So this one here in the first box is what we'll call the zero product property. And then this one down here, it's not labeled, but it's called the square root property or the root property. And these are the two things that we need to know back from chapter 1, which was the review chapter, in order to do the stuff that we're talking about today. Oh, thanks, Brittany. I just noticed you said that was an accident. Okay, so the first is the zero product property, and we'll see it when we're factoring. So let me tell you what it says, right? So the zero product property says you give me two real numbers, a and b. Okay, so again, these are two real numbers. If you multiply those two numbers together, a times b, and the answer is 0, right? So you multiply a and b together, that's the if part of this statement, a times b is 0. Then the only way that that is possible is if either the first number was 0 or the second number was 0, okay? That's the only way you'll get 0 for a times b. And it makes sense. If a is not 0 and b is not 0, you multiply them together, you're not going to get 0, right? The only possible way you'll get 0 is if either the first or the second term was 0. And we'll use this when we factor, right? We'll take a quadratic on that left-hand side, that ax squared plus bx plus c, and we'll factor it into two pieces. And then if it's set equal to 0, one of the two pieces has to be equal to 0. So that's where we'll use that, right? So that's the first thing we have to remember back from chapter 1. And then the second is that when we're trying to isolate an x squared, right? So when we're trying to solve for x, if we're trying to isolate an x squared term, we should take the square root of both sides. For example, if we have an equation like this, x squared is equal to k, where k is non-zero. So let's suppose x squared is equal to k. Then what we'll do is we'll take the square root of both sides of the equation, the square root of this side and the square root of this side. And we'll get the square root of k on this side. And then the square root of x squared will just give us back x. However, remember that there are two types of square roots. There's the principal square root, which is the positive one, and then there's another square root, which is actually negative. So that means that we have to add on a plus or minus, right? There are actually two solutions to this equation. If this is equal to 0, then there's only one solution. If x is equal to 0, but typically we don't write plus or minus 0. Just plus or minus 0 is just 0. Okay, so really what it's pointing out here is how you undo a square is take the square root of both sides, but remember when you do that, you get a plus or a minus, okay? And we'll need that when we're completing the square. That's the sort of the key feature to solving problems with completing the square. And I'm gonna, again, leave it up for a moment in case somebody's writing this down. When you guys are done writing it or you have enough info there, give me a thumbs up again and I'll sort of go from there. And that way I know when everybody's had more than enough time. And again, if you've missed something, just let me know in the chat and I'll come back and take a moment to wait too. It's good to make sure that you understand what's being said here. So if you have a question, this would also be a good time as well. Okay, cool. So I think everybody's had enough time. Let's go on to do just like an example of a factoring problem. And I'm going to do an incredibly simple one first. Okay, I think I made the mistake last time in my last class. I teach the same class right before this one. I made the mistake of doing the hard one first. So let's do the easy one first, just to make things a little bit easier here. This question that we'll look at is, let's solve x squared plus 5x plus 6 is equal to 0. And this one's pretty easy because the a is 1. We'll find that anytime the a is 1, it sort of makes our life a little bit easier. And when you're confronted with a quadratic equation, the first thing that you should try to do is put it in this standard form. So move everything to one side of the equation, and then see if you can factor that side of the equation. And you should put it in this form first before you factor, because we need to use the zero factor property. One side of the equation has to actually be equal to 0. If you just factor and set pieces equal to something else, it's not going to work out. We're using the zero factor property. Okay, so once you have it in the chat, tell me what the two factors are here. What does this factor into? Just as a helpful hint here, this one has to be x and this one has to be x, because it's x times x because it's x squared. This is positive and this is positive, so they're both going to be positive. Okay, yeah, and then 3 and 2, because 3 times 2 is 6, 3 plus 2 is 5. So when this is 1, the factoring is pretty easy to do, right? But remember, when you did the homework assignment, there were some examples where it wasn't so easy to do the factoring. And the next one that we'll look at is one where it's a little more difficult. But here, what we'll now do is the zero factor property, okay? So the zero factor property tells us that the only way the product of these two things is equal to 0 is if either the first one was 0 or the second one was 0. Okay, that's that zero factor property. Okay. And now we can go through and solve each one of these individually. This one gives us x is equal to -3, and this one gives us x is equal to -2. And these are the two solutions to this equation. So if I were to plug in -2 here, I would get 0, or if I were to plug in -3, I would also get 0 as well. Okay, and it's typically the case that you'll either have two solutions or one solution. Okay, two solutions or one solution. So that's a pretty straightforward one, and you'll notice that it's really easy if you can do the factoring. Okay? So let's do one that's a little bit harder. Maybe you won't see the factoring right away, but we'll see how many steps it takes with factoring. And then we'll try and do the same problem in a little while using the method of completing the square, just so we can see the difference between the two. Now, the nice thing about completing the square with this problem is that it's more algorithmic, right? There's no sort of guessing or thinking about factors or anything like that. You just compute things and follow the algorithm for completing the square. Okay, so here our A is 6, our B is 7, and our C is -5. And again, before you try anything at all, you should try to factor this and then set the two factors equal to 0. So before you go on to completing the square, before you go on to the quadratic formula, see if you can factor, okay? I should say that because this is negative here, one of these is going to be positive and one of them is going to be negative. So that's something you can see sort of immediately. Now, this problem's a little bit harder because here we have a 6x squared. It's not just an x squared. It's not just a 1, okay? So we'll need to think about the factors over here. So here we could put something like 2 and a 3 or a 6 and a 1, right? But we have to think about what the different options are. Brian, be careful. You can't just put both x's there, right? Because if you have two x's there, you'll multiply them together and just get x squared and not a 6x squared. Okay, so Angelique has 2x minus 1 times 3x plus 5. And that's a good choice there, right? Because the 2x times the 3x is going to give us that 6x squared. The negative 1 times the 5 is going to give us the negative 5. Now, all we have to do is check to see if the 7x works out, right? And that's typically what I'll do with these problems, right? Go through the FOIL method. Now, if you're still struggling with that, there's a nice video in Affinity that's been added to some of these questions that'll help you review that process if you're still struggling. And I think they actually do the little triangle sort of thing and all of that. But typically, I'll think about just unfactoring this. In this case, it would be 2x plus 1. I'm sorry, not 2x plus 1. 2x minus 1, and then the 3x plus 5. Okay. And let's go ahead and see why. So the 2x times the 3x, that's the first, gives us 6x squared. And then we'll have the outer and the inner, right? So the outer here is 10x. The inner is negative 3x. 10x minus 3x, that's the 7x, okay? And then finally, the negative 5 times the 5, I'm sorry, the negative 1 times the 5 is just that negative 5. So, yeah, here, I mean, if you don't see exactly what the factoring is, it can be a really tough problem. So if you don't see immediately how to factor it, it may be worth just going to the quadratic equation or the quadratic formula for you. But here, once you have that, then you set them equal to 0. So you set this guy equal to 0 or this one equal to 0. And again, remember what we're doing when we do that is we're using that 0 factor property. The only way that we're going to get 0 here for this guy, the product of these two guys, is if one of the two factors equal to 0. Okay, and Jordan is chiming in with exactly what I want you guys to do next. What is the solution for this one, right? What do we get for x here? So as soon as you have it, type in, what do we get for this one? Okay, Dalton's got it, Destiny, Melissa, okay, great guys. We're going to add 1 and then divide by 2, right? So we get 2x is equal to 1, divide by the 2, and there we get x is 1/2. So if we were to plug in 1/2 into this formula for x here and here, we should get 0, okay? That's a good way to check your work. And then this one, we'll subtract 5, and then divide by 3. Okay, so we've got some nice rational numbers here. Okay. So again, another one by factoring. We'll do this one by completing the square, and we'll see that we don't really have to do any guessing or anything like that, right? There are a lot of different options here for the factors, but if we complete the square, it's just algorithm, right? You just do the step by step. There'll be more steps, but there's no sort of guessing that you have to do. Okay. So the goal here, or the statement, is just remember that if you can factor, you should. It'll make your life easier, and it's the fastest way to do it. In terms of showing work, you don't have to say you're using the 0 factor property, but you should have this step here, right? So remember that in your notes, you have to be submitting your supporting work for your Affinity homework, and this is the kind of thing I'd be expecting for factoring. Okay, so let's now talk about completing the square. And I think it's best, instead of talking about it very abstractly, to do it with an example, okay? So I'm going to both write out the algorithm for it, but at the same time, we're going to solve a quadratic, okay, using the method. And the quadratic we're going to look at is x squared plus 4x plus 1 is equal to 0. Okay? And certainly in this case, this guy doesn't factor for us, right? There's nothing that's going to factor really nicely in this case. So we really are going to have to use the quadratic formula or completing the square to do this. Okay, and remember the other property we had was that square root property. So at some point we're going to use that square root property. So let's talk about what you do here. Okay, so let's suppose we're given a quadratic equation and we can't factor it. Here, they're supposing that the a is 1, and it turns out that you can always make sure that the a is 1 if you just go back and if you start with your quadratic here, you could divide both sides by a, right? If I divide both sides by a, I'll get x squared b over ax plus c over a, and then 0 divided by a is just a, because again, a is not equal to 0. So you can always get to the point where, sorry, let me get back to this page, where the a is equal to 1. But here we're just going to make it a little bit simpler and go through an example where the a is 1. Okay. So this is the example we're looking at. And your first step here is to isolate the x's on one side of the equation, right? So first add or subtract whatever the constant term is to the right-hand side of the equal sign. So here what we did was just subtract the 1, right? So they got x squared plus 4x is equal to negative 1. It's an equivalent equation. And again, what we're after here is we're solving the equation, so we're trying to isolate the x, right? So your first step is to put all the x's on one side and make sure that the x squared has 1. Okay. What's the next step? Okay, well, you'll just have to bear with me, right? Let's just talk about what we'll do on this step. And then in the third step, it's going to make a lot more sense, right? But again, it's an algorithm here, so you'll always do the same step. So now what you'll want to do is figure out what term is next to the x in this equation up here. In this case, it's a 4, okay? I'm going to refer to that as b. But it's whatever's next to the x here. And what you do is you multiply that b, whatever's next to the x, by 1/2, and I'll explain why in a moment, and then you square it. Okay? So let me write that on the board. So you take the b, you multiply it by 1/2, and then you square it. Okay? So you take the b, you multiply it by 1/2, and then you square it. So let's see what they did. So here's the b in this case. They multiplied that b times 1/2. So 1/2 times 4, half of 4 is 2. So that's what they did first, right? So they did first this 1/2 b, and in this case it was 1/2 times 4, which is just 2. Okay. Is everybody following along with me here? Jordan, did I pause? Is everybody seeing what I'm seeing? I think I see somebody in the chat here. Can't see. Okay, Dalton can see. Let's just make sure the majority of us. Oh, I'm sorry. Sorry, guys. I'm jumping down below. Let me scoot back over here. Thank you. Thank you. I see what you guys are saying now. I appreciate it. Okay, there we go. So, yeah. So what I was saying is we take 1/2 times the b, and we square it. And here, the first step they did was just take 1/2 times that b, which was 4, and they got 2. Okay. And then now, they'll just plug it into this, right? So again, they got 2 here. So this is just going to be 2 squared, which is 4. Okay, these two numbers are incredibly important. You should do this sort of as side work when you're completing the square. Okay, so that's what I was saying there. Thank you guys for pointing that out. Okay, so coming back here, they take that b times 1/2, which was 2, and they square it. Okay, so here, that's what they're doing here. And they get 4. And this 4 is incredibly important, and it's where the term completing the square comes from. Because on the next step, part 3, what you do is you add that 1/2 b squared, which in this case was 4, to both sides of the equal sign. Okay? So you just add that to both sides of the equal sign. So up here, you had x squared plus 4x is equal to -1. And then you just add this b, 1/2 b squared to both sides. So here you're going to add on the 4, and then you do it to the other side as well. Okay? So you just add on that 4 to both sides. And you simplify things. So here on this side, you get x squared plus 4x plus 4, and on the right-hand side, you get 3. And you might be asking yourself, what is the purpose of this? This looks like a more complicated equation, but it's not. If you stare for a moment at the left-hand side, this x squared plus 4x plus 4, you added in the correct term so that this is now a perfect square, okay? For example, 2 times 2 is 4, and 2 plus 2 is 4. So this left-hand side is actually going to factor into just x plus 2 squared, okay? It's just x plus 2 times x plus 2. And that's where the terminology completing the square comes from. On the left-hand side, you're going to get a perfect square, and the term that you have to add in is the b over 1/2 squared. So that's the term that completes the square, and you get a perfect square. So that's what this next line is saying. The left-hand side can now be factored into a perfect square. And it will always factor into a perfect square. You're adding on just the right term in order to do it. And in fact, there's a little bit more here. So let me go back to the board so you can see everything, right? So here, let me go through what they just said there. We added the 4 to both sides, so we get x squared plus 4x plus 4 is equal to 3, because 4 plus negative 1 is 3. And then this side gave us this x plus 2 squared is equal to 3. Now, what I want to point out here is that this part is always going to end up being x plus b over 2, or the 1/2 b. That's that 2 part. So if you compute the 1/2 b squared and the 1/2 b, you'll have this part already done for you, okay? And then now, let me just finish this off here and solve for x, because now we can use the square root property. So what we'll do is we'll take the square root of both sides, so the square root of that side, and the square root of this side, okay? But when you take the square root of both sides, you have to get a plus or minus, okay? So on this side, the square and the square root cancel each other out, so you get x plus 2 is equal to plus or minus the square root of 3. And then you can just solve for the x. So move the 2 to the other side, and you get x is equal to negative 2 plus or minus the square root of 3. And we have 2 answers here. There's one for the plus and one for the minus. So this gives us x is equal to negative 2 plus the square root of 3, or x is equal to negative 2 minus the square root of 3. Okay? And those are the 2 answers here. Again, we move everything without an x to the right-hand side. We figure out what completes the square. That's that 1/2 b squared. We add that to both sides. We complete the square and take the square root and just solve for the x. Okay? So let me come back to this guy. That's again what they're saying here in number 4. And in this example, they're factoring it into x plus 2 squared. So Wilson, the 3 came from the fact that we added 4 to the right-hand side. So that was that negative 1 plus 4 gave us a 3. You can see that here. Okay, so what we did was the final step here, number 5. We used the square root property then to solve for x, right? So we took the square root of both sides, we got our plus or minus here, and then we solved for the x. And then we got these 2 different solutions. Okay, so that was, I guess, this guy down here and this one over here. Okay. I'm going to leave this up. If anybody needs me to go back or needs to write a little bit more down, let me know, and I can take a step back. If you're done, give me the thumbs up down there in the chat, and then I'll know we can just move on to the next slide. Okay. So you can see that it's a very algorithmic process, right? There's no sort of guessing factors or trying to sort of figure out some reverse foiling process or something like that. It's just a straightforward algorithm, okay? So let's actually do an example. And let's do an example that is difficult, because Affinity is not going to give you a lot of really simple examples. So let me show you my whole board so I don't miss some stuff. And we're going to do this, I guess this is our 3rd question. Yeah, this is our 3rd question. It's the same one as the previous one that we did, right? So the one that we did with factoring. But now I'm going to ask you to do it with solve by completing the square. And we're going to look at, again, 6x squared plus 7x minus 5 is equal to 0. So this is the same one that we had previously, but what I'm assuming now is that maybe you didn't get the factoring correct, or you couldn't figure out how to factor it, right? So now what's your next step? Well, you can either go to the quadratic formula, or you can try to complete the square. So let's go through that algorithm of completing the square. So those steps that we said before, the first one was to move the 5 to the other side, right? So move everything without an x to the other side. So if we do that, I'm going to start over here just so we have enough room to move to the next side of the board here. We're going to get 6x squared. So this is the solution here. So we're going to get 6x squared plus 7x is equal to 5. Okay, so that's just adding the 5 to the other side. Now, before we do anything, we need to make sure that what's next to the x squared is a 1. And we can do that by just dividing by whatever's next to the x squared. And in this case, that's 6. So we're going to end up with a bunch of fractions now. So x squared, I divide by 6 here, and I just get x squared. This one, I get 7 over 6 times x. Because 7 divided by 6 is just 7 divided by 6. And then on the right-hand side, 5 divided by 6, you can just write it as 5 over 6. So I divided by the 6 to make sure that this is now a 1. Okay, so we've completed the first step in that algorithm. Okay, so now on the side, we should think about 1/2 times the b and 1/2 times b squared, right? Those are the pieces that we needed to complete the square. And we shouldn't use the b from up here. That's a little bit of a misnomer there. We need to use what's next to the x here, okay? So right here, we would get 7 over 6, I'm sorry, 1/2 times 7 over 6. Okay? And when you multiply fractions, it's just top by the top, bottom by the bottom. So this is 7 over 12. Okay? So we're going to need that when we factor, right? When we get that perfect square factor, 7 over 12. And then we need to square that. So here we're going to get 7 over 12 squared. 7 squared is 49. 12 squared is 144. Okay, so that's just side work, right? That's the piece that we need to do in order to complete the square. And you'll notice there was no guessing here. Like, it wasn't like when we were factoring the 6 and the -5 there. We just went through and identified whatever was next to the x, divided by 2 and squared it, or multiplied by half. So multiplying by half is the same thing as dividing by 2. So this is now, I mean, it's an ugly fraction here, but this is now what we need to complete the square. So we'll add it to both sides of the equation. So here we get x squared plus 7 over 6x plus 49 over 144 is equal to 5 over 6 plus 49 over 144. And again, the purpose of this, adding in this term, is that now the left-hand side of this equation is a perfect square. So this will factor into a perfect square. And because we had a 1 there, it's going to be x and then something here. Okay? So let's start off with a couple of questions. The first one is, what goes here? What should I write here? It should be, is it x plus something? Is it x minus something? And what number is it? And just as a quick hint, it's already on the board. Okay? The number is already on the board. Okay, so most of you are identifying that it's a plus. That's correct. But what number should we put in there? X plus what? Okay, so Jordan here gave us the right answer. It's always going to be this b over 2, 1/2 times b, right? So that's why I compute that and then square it to get this guy. This is what you add, and this is how it factors. So here, this is going to be x plus 7 over 12, and that will always happen, right? And you could FOIL this back out, and you'll find out that it's actually equal to this, okay? So that was the purpose of adding 49 over 144 to both sides. Okay, now we need a common denominator. The common denominator here is actually 144. So you need to multiply the top and bottom by something in order to add these two fractions. Again, this is 5/6. So go ahead and add those two fractions, and then once you have it, write it in the chat for me, what numbers you have. Remember, you need a common denominator there to add those two fractions. Okay, and I think Jordan's moving pretty quickly here, so I'm going to wait for a couple other people to chime in with what their answers are. If they agree with you, Jordan. They disagree with you, Jordan. Oh, you're perfectly fine. Typically, I'm just looking for answers just so I know people have enough time to, like, write it down and think about it and stuff. But I do appreciate you giving me your answers, so don't stop posting. Okay, Angelique, Destiny, everybody's seeing sort of what's happening here, right? So if you rewrite this, it's going to be 120 over 144. 120 plus 49 is 169. So this becomes 169 over 144. Okay? And that was that goal, right? I mean, we have something now that the square is equal to a number. And so now we can use the square root property to just take the square root of both sides, right? So here, I'm going to take, let me move this equal sign over because we're going to have to put a plus or minus. Let me put it right here. So on this side, I'm going to take the square root of this side. Okay? That's a square root. And then we have to take the square root of this side. And we get a plus or minus. Ali, we added these two guys together. The common denominator is 144. Here, when you rewrite this as a fraction of 144, you get 120 over 144. 120 plus 49 is 169, and then the denominator stays the same, 144. So you have to find that common denominator of 144 first. Okay. And then when we use the zero factor property, we get that plus or minus. Okay. So here we get x plus 7 over 12 is equal to plus or minus. Now we take the square root of 169 and divide it by the square root of 144. The square root of 169 is just 13, and the square root of 144 is just 12. Okay, so we're, again, after isolating x on its own. Okay. So now the next step is to subtract the 7 over 12 from both sides. And let me move up over here. So here we're going to get x is equal to negative 7 over 12 plus or minus 13 over 12. And we get two different okay, so what do I need to multiply the top and bottom of this by? Can somebody tell us what we need to multiply top and bottom by here? By 24. Okay. And what's 24 times 5? Okay, good. All right, so now we're over here, and this one fortunately has the same denominators for us, so we don't have to do Destiny, it's so that we get a common denominator of 144. So 24 times the 6 is going to give us the 144. So we need to multiply the top and bottom by 24. Just trying to get that common denominator. Okay, so this one, remember, is going to give us two solutions. The first is x equals negative 7 over 12 plus 13 over 12. And the second is x is equal to negative 7 over 12 minus the 13 over 12. Okay, so add those together and subtract them and then put in the post what the answers are. And they should be familiar. Okay, what do we get for that first one? What do we get for the second one? And remember here, when we're adding these, we'll just keep the denominators as 12 there in the bottom. So add them together, subtract them, and then tell me what you get for your answers. Okay, we definitely get 1/2 for this one, right? So here, 13 minus 7 is 6. So 6 over 12 is 1/2. Yeah, so 1/2 is correct there. What about this other one? Here, we're going to get a minus and a minus. So negative 7 minus 13, that's going to give us the minus 20 over 12. And minus 20 over 12 is negative 5/3. Okay. Yeah, so the negative 20 over 12 gives, and that's exactly the answer we got from factoring. If you remember, we factored this guy and we got these same two answers, 1/2 and negative 5/3. But you'll notice here, this one's, although you're doing more steps, everything is algorithmic, right? There's nothing here that you have to guess. There's no sort of factors that you have to think about. You just compute these two guys and go through the process. Okay, But you can see that with the fractions, it can be a little bit tough, right? So sometimes when you've got to throw fractions in there, you have to remember sort of some of those details. Okay, so we only have about 10 minutes, so we need to get through the quadratic equation and at least do one example there. So let me go ahead and go forward with that. That was subtracting the 7/12 from both sides, right? So over here, we had this plus 7/12, so we subtracted it from both sides, and that's why it became negative. Okay, but we need to go on to the next detail here. And I'm going to go through this pretty quickly. If it is a little too fast for you, I would recommend you coming back and watching the recording again, or maybe even reading the textbook. Now that you've seen it sort of happen with some numbers for A, B, and C, we're going to do it just in general, right? So what you're seeing on the board there, or up on the slide, is completing the square, but just for an arbitrary A, B, and C, okay? So let's say we started with this ax squared plus bx plus c is equal to 0, okay? The first step we would do is we'd isolate the c on one side, or the x's on one side. So subtract c from both sides. Then we'd want to make sure that the leading coefficient, the one that's next to the x squared, is a 1. So we would divide both sides by a. Here we get b over a, and here we get c over a. And that's what we did in the last example, right? We divided by that 6. Okay, and then now we can take whatever's next to the x, multiply it by a half, and then square it, okay? And what was next to the x? It was b over a. So here we get b over a times a half squared. And when you square the top, you get b squared. When you square the bottom, you get 4a squared. So this is the term that completes the square. So we'll add it to this side of the equation. So we're going to come back to this and add it to this side of the equation, the left-hand side, and we're going to add it to this side of the equation. Okay, so there it is. B squared over 4a squared, and b squared over 4a squared. So we just added it to both sides of that equation, and so we end up with this complicated-looking one here. And the point of all of this, oh, sorry guys, the point of all of this is that now this side is a perfect square, right? And it's going to be x plus whatever the 1/2 times the term in front of the x was. So in this case, 1/2 b over a squared. And then you've got b squared minus 4ac over 4a squared. Okay, so now you take the square root of both sides of this equation, and you get a plus or minus, and you solve for the x. And when you do that, you get this beautiful equation here, which is often referred to as the quadratic formula. So anytime that you use the quadratic formula, what you're essentially doing is skipping the steps of completing the square. So completing the square is where the formula comes from. And let me talk a little bit about this formula. You'll need to know this formula for the exam. It's not going to be given to you, and you will be expected to use it. Those of you not going on to calculus, this is one of the most important parts of the course, because a lot of classes that use this as a prerequisite that are not math courses will expect you to know how to use this quadratic formula. Okay, so it's pretty easy. Once you know the formula, it's negative b plus or minus the square root of b squared minus 4ac, all of it divided by 2a. All you have to do is identify what a is, what b is, what c is, plug it into the formula, and simplify. And here, it's really important that the a was not 0. Remember, that was part of the definition of a quadratic equation, because you're going to divide by the 2a. So you need to make sure that the a was not equal to 0. Okay, so this is our formula. The most important part of this formula is going to be this here. This isn't part of our learning objectives, but it is part of the Infinity homework. There are, I think, 3 questions at the very end related to this part that's underneath the radical, the b squared minus 4ac. There's a name for that term. It's called the discriminant. I'm going to bring it up here in a moment on the screen, an actual slide with that term. And it tells us all of the information about what types of solutions we have. If b squared minus 4ac is positive, then we can take the square root and we'll get 2 solutions, one plus that square root and one minus that square root. So when b squared minus 4ac is a positive number, we get 2 real solutions. When b squared minus 4ac is negative, we get the square root of a negative number, and so we end up with a complex number. And I'm going to show you, that's going to be the last example we'll talk about today. you get a complex number as your answer. And actually, it turns out they're complex conjugate pairs. They have to be because of this plus or minus that you're seeing here. Okay, and then the last possibility is that b squared minus 4ac, this could actually be 0, right? Whatever's underneath this. And negative b plus 0 is the same thing as negative b minus 0, so you'll only get one solution. So that b squared minus 4ac tells you if you have complex solutions, 2 of them, if you have 2 real solutions, or if you just have one solution, okay? So let me summarize that in a slide now. And that's what's being said here. You start off with ax squared plus bx plus c. A, b, and c are real numbers. And we define the discriminant to just be what's underneath that square root in the quadratic formula. B squared minus 4ac. And we check to see if the discriminant is equal to 0, if it's positive, as in these two cases, or if it's negative, right? So being less than 0 means that it's a negative number. This means that it's a positive number, this means that it's equal to 0. And there are at least, I think, 2 or 3 questions at the end of this section that ask you to just compute the discriminant. You don't even need to solve for x. You just compute b squared minus 4ac. And that tells you if you have one solution, if you have 2 solutions, or if you have a complex solution, okay? So there you don't actually need to solve for x to answer the problem. You just need to compute that discriminant. Now, it's not part of the learning objectives, so it's not going to play too important of a role in the course, but you should be aware of it and the terminology discriminant. So let me finish off here with an example of that, and then we'll be done for the day, okay? So the example that I want to do is the following. Let's solve 3x squared plus 2x plus 1 is equal to 0. And the first time you look at this problem, you should think to yourself, does it factor, right? And you may want to try and factor that. And you'll find out that, in fact, it doesn't. But you should try at least a couple of things first and see if you can see it, because it's easier. And then you might think to yourself, well, maybe I could just complete the square if you know the algorithm. And that's good practice for those of you going on to calculus. It would be a good idea to complete the square here and try that out. But if you do that, you're going to have to divide by the 3, and there'll be a bunch of fractions floating around. So you'll have to keep track of all those fractions and all that sort of stuff. So it may be the case now that if you're going to have to deal with all those fractions, it doesn't factor, that your best bet is to use that quadratic formula. Negative b plus or minus the discriminant, b squared minus 4ac, all of it divided by 2a. And all you have to do is go to this equation and figure out what a is, what b is, and what c is. So in the chat box, chime in with your answer for a, b, and c. What did you get for a? What did you get for b? What did you get for c? Okay, yeah, so I just made it so that it counts down 3, 2, 1. So here's the a is 3, the b is 2, and the c, the constant term, is 1. Okay, so all you do is go through and replace all of these terms with those values, okay? So here you get b was 2, so that's negative 2, plus or minus the square root of, I'll write 2 squared minus 4. The a was 3, so I'll put it in parentheses here, and I'll explain why I'm doing that. And then the c, I'll also put in parentheses as well, the whole thing divided by 2 times a, which was 3. I usually put the a and the c here in parentheses just because sometimes they can be positive and sometimes they can be negative. So if you put them in parentheses, it's easier to keep track of how many negative signs there are. Anyway, so in the chat box, take this discriminant and figure out the discriminant, the 2 squared minus 4 times 3 times 1. And tell me what we get in that discriminant. On the bottom, it's just 2 times 3, so it should be 6. Okay, everybody's got negative 8 here. So this is 2 squared, which is 4. And this is 4 times 3, which is 12. Times 1 is still 12. And then that 4 minus 12 gives us negative 8. And immediately we know that we're going to have complex numbers as our solution because we're taking the square root of a negative number here. Now, you can think about this in the following way. So let me move now up to this position here. So think about it like this, -2 plus or minus the square root of -1 times the square root of 8, all divided by 6. Now, you normally wouldn't write this, but I just want to write it in this format because if you remember, our definition of the square root of -1 was just that it was I. Right? So we're using that multiplication property of square roots, and now we're writing this as I times the square root of 8. Remember, the square root of 8, we can simplify. 8 is 4 times 2, so this is 2 root 2. So this is -2 plus or minus. I'm going to put it in front, 2 root 2 times the I. I is that imaginary number, all divided by 6. Okay, so -2 divided by 6 is -1/3. And again, 2 divided by 6 is 1/3 as well. So this is the square root of 2 over 3 times the I. And these are the two values of x. So there's -3 plus the square root of 2 over 3i and -1 over 3 minus the square root of 2 over 3i. And you'll notice that, in fact, they're complex conjugate pairs. And any time that you come up with a complex solution to a quadratic equation, if there is a complex one, its conjugate will also be a solution as well. Okay? So here, there are a couple of questions in infinity where you end up with complex numbers as your answers. Okay, so just one last thing here. Let's come back and remind ourselves of the learning objectives. We talked about solving things with quadratics and the zero factor property. That's your best bet for solving it if you can. Then we talked about the process of completing the square. This is really important for those of you going on to calculus. And then quadratic formula. And remember, the quadratic formula came from completing the square. That's probably the easiest way to go about things because all you do is plug it in and simplify it. But remember, it still can get complicated because you might end up with some of these complex solutions. I'll be around for the next 10 minutes or so. I'm going to stop the recording, so if you have a question, you can ask then. Thanks for being here today, guys.